Hi everyone, welcome to this episode of Keipert Labs. We're going to be talking about what's an ion. So far in this topic we've been looking at revisiting the structure of the atom, looking about how it's made up of protons, neutrons and electrons, talking about the nucleus and energy shells, electron shells. And so now we're going to introduce this extra kind of layer of understanding on what we're doing now, in introducing this key word. So we're going to look at a couple of examples, and then we're going to kind of explore some definitions. So the first thing that we're going to start with to help build our understanding of this is that we're going to have a look at a sodium atom. Okay, so we've got sodium. I'm going to see if I can do a simple representation here for you. Okay, so sodium, so we have a positively charged nucleus in the middle, and then we've got 11 electrons going around the outside. 1, 2. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and so then we have these. So these electrons are orbiting around this nucleus in these energy shells that we talked about before. Okay, so then looking at this atom of sodium. Okay, inside its nucleus, so we've got 11 protons and 11 electrons. So 11 protons inside the nucleus and 11 electrons orbiting around the outside. Okay, we talked about this idea that an atom is balanced, so it has a charge of 0. Okay, that it's neutral, that we have this precise balance of positive and negative charges. Okay. But what we often see with this sodium atom is that this electron, you can see that we've got 2 in here. Okay, we've got 8 in here. Both of these, this first shell and this second shell, are full. But then this last one's got 1 electron by itself in it. And what often happens to this sodium atom is that this 1 electron, that lonely one on the edge there, gets lost. Okay, so it loses 1 electron by giving it to another atom that will take that 1 electron and will make it a part of its structure. So what happens then is that we have this same sodium atom with the same nucleus, okay, and we've got those electrons in that first shell. We've got those 8 electrons in the next shell. But now we don't have that one that was on the outside anymore. Okay, so we still have, because our nucleus is untouched, we have 11 protons. But now, if we count them up, we've got 1, 2 plus 8 makes 10 electrons. Okay, so now what we've talked about in the past is that protons are positively charged and electrons are negatively charged. We now have one less negative charge than we did before. That is to say, we've got 1 more positive than we do negatives. So what that means is that now this atom has an electric charge, and it has an electric charge of +1. And so what we say is that we don't call it an atom anymore. We call it an ion, a sodium ion. And so when the sodium atom originally had a symbol of Na, to try and distinguish, actually I might rewrite that up here so it's a little easier for you to see. Okay, where the sodium atom was Na, we now want to express that this sodium ion has a charge, and that we put a little plus in the top right hand corner just after writing its symbol. So Na plus, to show that this is a slightly different thing than it was to start with. And so, you notice I've got a +1 charge, but I didn't write the 1 up here. Okay, just because if there's no other number, we can say that it's a 1. Alright, so in this situation we've got an atom that's lost an electron, and 1 electron specifically, to become this thing over here, which we call an ion. Okay, and so now what we're going to do, we're going to have a quick look at an oxygen atom. Okay, so what we see with an oxygen atom, we're going to see that we get something a little bit similar, but it's not quite the same. Okay, so oxygen. Okay, so oxygen has an atomic number of 8. Okay, so we've got our positive nucleus in the middle, and we've got 1, 2, 3, 4, 5, 6, 7, 8 electrons going around the outside. Okay, so we've got 8 protons and 8 electrons. Okay, we've got an exact even numbers of each, and it has the symbol of O, capital O. And so what we see with an oxygen atom, rather than losing electrons, is that we see that in the previous example we said that the second shell, this second kind of ring that we can draw around the outside, is full when we have 8. And so we're too short of having 8, 2 electrons short. We could fit another one here and another one in here. And so what that oxygen atom will often do is it will gain 2 electrons to fill those spaces, to get up to that level. So we've got our same positively charged nucleus, we've got 2 electrons here, and now we've got 1, 2, 3, 4, 5, 6, 7, 8 electrons orbiting around the outside in that second shell. Now we haven't touched the nucleus, just like before, so we still have 8 protons, but now we count them up, we've got 10 electrons. Okay, so now we have 2 extra negative things, 2 extra electrons than we had before. So what that means that is instead of it having now, instead of it being neutral like it was to start with 0 charge, it's not positively charged because we have extra negative charges. It's negatively charged, and not just with 1, but actually with 2. So it has a charge of 2 minus, or minus 2. Okay, so it's got 2 extra negative charges than it started with. So when we had O over here, what we then do is we say, alright, well, to show that this is an ion, we put its charge in the top right hand corner, and we put the number first. We say we've got 2, it's got a charge of 2 minuses, 2 minus. Okay, so we have the oxygen atom, and we have this ion over here, which is called the oxide ion. So for something that was a non-metal, that we add this IDE ending to show that it's undergone this change. It's become something different from before. Okay, so we had sodium that became a positive ion. We had oxygen that became a negative ion with losing and gaining electrons. Okay, so we've talked about, okay, well this is, we're calling it an ion, but let's actually give a bit of definition to try and, take something away from this. Okay, so the way that we define an ion is an atom or group of atoms that have a charge. Okay, that's our definition that we're working with. So a single atom or a group of atoms that have a charge. And so that charge may be plus or minus, positive or negative. Okay, so we started with, if we have a neutral atom which has no charge, okay, we saw that it could become, we got 2 different types of ions out of that. Okay, the first one that we got was a positive ion, like our sodium. And so we give a specific name, a special name to things that are positive ions. We call them cations. Okay, now I realize that it looks like you'd say it cation, because like in location or vacation, but we pronounce it cation. We also and so that was like our sodium. Okay, but we can also make a negative ion, like we did with our oxygen, and we give this the name of an anion. Now it also looks like you should say like anion, like misspelling the word onion or something like that, but we pronounce it as anion, like our oxygen that we had there. So a neutral atom which has no charge can become either a positive ion or it can become a negative ion. It becomes a positive ion by losing electrons, or it becomes a negative ion by gaining electrons. Okay, So we said that it could be, one atom or a group of atoms that have a charge. Okay, in this example, we talked about single atoms that could become could have a charge. We're going to quickly talk about what happens when you have a group of atoms. Okay, and what we call that. Okay, so the term that we use is we say it's a polyatomic ion. Okay, so which is a group of atoms with a charge. With a charge. Okay, because poly refers to many in Greek. So we've got an ion that has more than one atom connected together. So they're connected together as a group, and that group has a charge. So I'll just list out a couple of examples that we have here. So we have nitrate, which looks like NO3 minus. Okay, we have sulfate, which is SO4, which has a 2 minus charge. And so we have just two examples. There are a number of different ones we come across in chemistry that behave like this. We'll learn a little bit more about how we can actually describe compounds that do this and ions that do this in a little bit more detail in a future video. Okay, so just to quickly recap, we've talked about how a neutral atom that has no overall charge can become this thing called an ion, which is an atom or a group of atoms that has a charge. It does so by either gaining or losing electrons to end up with a negative or a positive charge. We looked at the labels that we use to describe ions that are either positive or negative, and also looking at ions that have more than one atom connected together in a group. Alright, thanks very much for watching. Bye for now.